Welcome everybody to lesson 18. I want to wait a few minutes to see who else would come in a few minutes late, but we'll go ahead and get started and pick up with any questions later. My name is Jared Hooper, flight instructor here at CCA. I think I taught way back at the beginning of the course. It's good to see everybody again. There's a sign-in sheet up front. Pass it around if you haven't signed in already. We'll go from there. And then similar to last time, fair game, any questions, bring them on. I'll answer anything you got. Any open items or questions, concerns from like the midterm, we can go over them. I can pull up regs, whether you name it. Go from there. Or not. All right. The last two lessons, I think, were on weather systems, weather. One thing you'll learn is understanding the weather. When you're on the ground, you're going to spend a lot of time looking up. And the old saying is better be on the ground wishing you were in the air than in the air wishing you were on the ground. And it all has to do with weather. And you kind of turn into a meteorologist by the time you become a pilot. Data sources. So we'll talk about like weather products, different information you find in those products, and why they're important and why they're an essential part of your pre-flight briefing for 91-103. For anybody who's interested in reading regulations. Service outlets. So most of the time, 90% of the time, your weather sources are going to be government regulated or government contracts, and disseminated through private facilities sometimes. A lot of times the FAA, NOAA, NASA, and the National Weather Service, they work in conjunction with all the different facilities across the country, all the installations at different airports that feed back into those models, as well as balloons and other things around the country. Flight service stations. So these, back in the day, they used to have flight service stations like at many airport facilities. Now they're sporadically located across the country. Most of the times remote locations. And that's why when you look at the sectional, you'll see RCO, remote communications outlet. So like Millville Radio. They're sitting in Virginia somewhere, but they'll talk to you out of Millville, New Jersey. Transcribed weather broadcast only if you go in Alaska. Not too many people make it that far up there, but in case you do, you'll get weather. And there used to be a lot more of this when I got my license initially. But now that many of the VORs are being decommissioned, except for the minimum operational network, you don't see this as much anymore, except up in Canada. Canada and Alaska, you'll see weather distributed over like man-made facilities. And they'll have everything from surface weather, adverse conditions, PIREPs, density, altitude, stuff you kind of see in an ATIS. Flight service station. So one of the ways, especially if there's no cell service and you have a landline and there's no internet, you can call 1-800 weather brief from anywhere in the US and Puerto Rico, any US territory, and get a weather briefing for your flight. You can get the telephone numbers in the chart supplement, but honestly, I've never called any other phone number except 1-800 weather brief. Yeah, so part of your pre-flight checklist, besides the regulation saying that the pilot in command shall be aware of any and all information relevant to the flight, getting a proper briefing is probably one of the most important pieces. That way, one, you can make sure that it's within your personal minimums that you can operate in those conditions, and two, that you're appropriately rated, instrument rated, or type rated for that aircraft that is flying in those conditions. There are three main briefings: standard, abbreviated, and outlook. So if this is the first time you're calling, actually, they may go into them in another slide. Standard briefing, first time you're calling, this is where you'll get the full briefing on all the conditions that we just talked about. Abbreviated is if you're calling back within like 4 hours or something, and you just want an update from the last time that you got the standard briefing, and an outlook is for more of a prognostic briefing 6 or more hours in advance. Now, if you have ForeFlight on your iPads that you're using for training, as an example, I think FlyQ or Garmin also have these tools. You can put your flight plan in on the map, go to the flight section on your EFB, electronic flight book, and hit the briefing button, and it'll go through. It keeps a log of when you accessed it, and it'll, when you actually file a flight plan, ForeFlight will send you an email with all the METARs and TAPs on route, which is pretty cool. You can go back and look at it. It's a good legal record too. If you ever get in an accident, the FAA says, "Did you complete a briefing for you?" So so when you make your initial call, you can call that 1-800 weather phone number. You tell them whether you're flying VFR, IFR, what your aircraft is, good afternoon, weather briefing. This is November 16237, VFR from Chester County, or Kilo Mike Quebec Sierra to Lancaster, Lima November Sierra, at about time is it now? 6 o'clock. So let's just say 4 hours from now. 22:30. Departure time, we'll get to Lancaster at 22:45. It's not that far away. At 3,000 feet, direct. Estimated time en route 15 minutes or something like that. And what they'll do is they'll go through. They'll give you a complete weather picture from here to there. What the local surface observations are. They'll also give you this information in sequential order for your route of flight based on the timing. The first piece that they're going to give you is adverse conditions, like if you have any significant weather, thunderstorms, icing, hail, you name it. TFRs, temporary flight restrictions, NOTAMs, the airport's closed. This is not a great day of ice and fog, mist, low visibility. VFR not recommended if you can't maintain. Does everybody remember what the 4 different visual flight conditions are? Visual, well, yeah, okay, so that's your cloud clearances. But there's visual flight rules, marginal visual flight rules, instrument flight rules, and then limited instrument flight rules. So VFR, MVFR, IFR, LIFR, LIFR. So if you cannot maintain VFR, they will say VFR not recommended. Especially for those pilots who don't have their instrument rating. They will not tell you not to go, because you're a big kid now, you're the pilot in command. No one's gonna tell you what to do, but they will advise you, not recommended. And it is all recorded, so if you take off anyways, you know. The FAA could say you're reckless and careless, 91. Was it 13? And that usually does not end well for your certificate. So synopsis. This just gives you like a large picture of the contiguous 48 states, lower 48. In this case, there are separate charts for Hawaii, like the other outlying areas. You'll get like all your frontal information, high and low pressure systems, the major pressure gradients, and some of the values in millibars. And in this case, tropical storm Ian, if you have a depression or a storm or something like that. So let's see, since you went over this, what is this right here?
Low pressure.
The red L, yeah. Low pressure system. Do you remember which way that the air moves for a low pressure system?
Counterclockwise.
Counterclockwise, correct?
Inward.
Inward, close,
That's
50-50 shot, yeah, up. That's why, think about it, right? Is good or bad weather normally associated with low pressure systems? Bad, right?
Yeah.
Because updrafts, moisture goes up, that's thunderstorm development, squall lines, funnel, so most of the time. And so conversely, this little H over Chicago, high pressure spins clockwise and the air sinks and out. So, yeah, down and out, down and out, which is good because the clouds are going down and out. With the, you know, the air movement going down, there's not a lot of lifting force to take moisture up into the atmosphere for cloud development. So a lot of times on high pressure days, it'll be pretty clear, almost no clouds in the air. How about this blue triangle line? What's that? Cold front. This red one here. All right. This one here. Stationary. Stationary front. Yeah, occluded is purple. Same symbols. But all right. At altitude, I don't know if you guys learned this, but here's an extra credit. What direction does the wind flow? If I was looking at this chart, could I tell you what the general direction of the wind is going to be at altitude? So how about Upper Peninsula of Michigan? Which way is the wind going? Upwards? So like this? Which direction do you think?
Northwest. Northeast side.
Like this?
Yeah.
Yeah.
Yeah, correct. So it's high pressure, right? Spins this way. So the winds are gonna go like this. And at altitude, they follow the pressure lines. The winds follow the pressure lines. When you get on the surface, they start crossing those lines because of surface friction. Yeah, they go against the isobars. It's not 90 degrees, it's more like 45, 30, depending on a lot of different factors. But at altitude, the winds follow the lines. So if you're going from New York to, I don't know, South Dakota, would I fly up towards Canada or would I fly to the south if I was heading west?
South.
Yeah, I would fly over Indiana because I want the wind behind me, pushing me along the way. If I go north, I'm flying into the wind the whole time. So you can use that information to like save time and fuel, like money, stuff like that. All right. Current conditions. So ceilings, visibility, winds, temperature. If departure is more than 2 hours away, it will not be included in the briefing, because the current conditions don't really matter 2 hours. You will get a forecast, but you won't get current conditions. That's really small, huh? I wonder, can everybody see that or no? Is that too small?
That's it.
Yeah, all right, the top, Boston, Boss. You know, have you spent any time decoding these yet?
Yeah.
Is it in this chapter? Oh, yeah, you're right, it probably is. Well, we'll get to it then. Let's not have too much fun for now. En route, so yeah. This is a forecast, area forecast. And it gives you information, like down here in the legend, they'll tell you. These are like arrows, flags, like pennants. The stick of the arrow is the wind direction. The feather on the arrow, black is the wind speed, red is the wind gust. So it's really hard to see. Like this would be out of the west, northwest, 5 knots, gusting looks 15 or 25, I can't tell. But we can go over some of that. And then this tells you visibility. So like red, and this kind of aligns with the colors. Green is VFR, blue is marginal, red is IFR, and pink is limited IFR. So when you see those colors, like little circles on an airplane, that's how you'll know, and breaks it down on visibility here. And then if there's like turbulence, low level wind shear, you'll see like tango, sigma tangos, and then IFR. Purple space for these maps. You also have like little symbols and circles, filled in circles, which is rain showers, fog, heat, like yeah, this is like fog or haze. Down here you have thunderstorms, the big R dot on top. And the more dots or stars for snow that you have, the more significant it is. Light versus moderate versus severe. Forecast. These are TAFs, terminal area forecasts, and we'll break down how to read these later. It's like another language. It's not too bad once you get the hang of it. Winds aloft. So this will tell you these here are either airports or nav aids. And they don't give you winds aloft for less than 3,000 feet above the surface, ground level. But you'll get the winds, direction, the speed, and the temperature at those altitudes and stuff. You can see the icing level in Ontario is around 16,000 feet. And San Francisco is right around 12,000 feet. Yeah. And if you got some crazy winds, 78, you know, 100. They're having lots of, you can see if you're gonna have, if you have like between like 6 and 9, you start seeing like 50 knot wind speed changes, you know you're gonna have wind shear. It's gonna be a bumpy ride going between those two later.
What are the 4 digits? I'm not following this.
We'll go through some of that later. I'll break it down.
Oh, okay.
I think there's a slide that helps me explain some of that. So let's get through that, and then we can look at the winds law. And because there's a few other anomalies here, that won't make sense unless you can read it initially. Notams, in this case, it says, taxiway Bravo 1, Bravo 2, Juliet, and Bravo North of runway 1432 are closed for aircraft greater than 150 feet. And it's, permanent. So basically from this date and time on, in perpetuity. You'll see that sometimes. A lot of times there's a end date and time. Many times it's like lights are out of service until they fix it. You can't use it or use like a navigational facility or a radio channel or something. And you'll get all of those when you do your briefing. ATC delays, VFR likely won't affect you. It's more of an impact unless you fly into like a Class B airport, which odds are really 99% of the time you're not going to. Especially VFR, but if you're IFR, you have to get clearance before you leave the ground. And if there's a ground stop in like New York or Philly, but you're in Chicago and it's crystal clear, they will not let you leave. They won't give you clearance. So if there's no sense getting the plane ready if you call up and they're like, yeah, it's gonna be another 2 hours. It's a waste of everybody's time. Any other pertinent information that comes up from PIREPs, pilot reports, or any emergency type broadcasts, they'll go over. Abbreviated briefing is just a shortened version to give you updates from the previous briefing. So they'll have your briefing on record and just annotate any changes since you last called. So if it's been more than a half an hour or something, it's a really good idea to go check that weather again, because things change. Outlook is basically like a forecast briefing if its departure time is more than 6 hours ahead. It's very limited scope. They'll give you like, should I get dressed or not, go, no go kind of decision, not really safety of flight type information. This is the website that I would say I use the most, and you may have already used. I've seen a few heads nod. Aviationweather.gov. They changed it over the last year or two, and they've gotten some better visual graphical tools and charts. So it's actually pretty nice. And this is they call the GFA, I think, the graphical area forecast. There's probably another name for it. But you can get all of the SIGMETs, AirMets, BIRAPs, METARs. METARs are current conditions, TAPs, forecasts. And then also up here, you can get winds aloft, icing levels, other things like that. Great place for information. Good supplement. Like if you're flying IFR and you know, the icing level tells you it's good. Like on Sunday, I was up on my way from Worcester, Massachusetts to Portland, Maine, and it was 6 degrees outside, and it was pretty much in the clouds the whole way up, and I started getting ice sliding off the lanes, and I'm like, that's weird. Probably because of the super cooled liquid droplets. So even though it's above freezing outside, you can have super cooled masses of basically rain ready to form in the cloud, which can freeze to your airframe even when it's above freezing. So I just got permission from ATC to drop a level and go right off. So all that type of information, you did your briefing. You could see, and if you were getting your clearance, you could request a reroute or something if ATC was trying to send you somewhere different, like they did me. using additional information. So this is for flight. And I could probably, at the end of this, I can probably pull up my ForeFlight account and show you what it looks like. If you're interested in something like that. I don't know how many people have ForeFlight or started training. How many people have started like taking flight lessons? About half. Do you have an electronic flight book or not yet? Okay. Not really important. It can be overwhelming, especially if you're learning. And, you know, it's most important to learn how to fly the airplane, not look at another computer screen while you're in the air. But it's another tool to help raise your situational awareness and help with your pre-flight planning and preparedness. So, lots of features that we can go through later. But briefing is definitely one of them. When you get into your instrument rating, I would say it's like 100% must to get a product like this. It's extremely helpful, especially when you're doing like single pilot IFR. Any questions on that so far? Besides wins and loss, we'll come back to that, I promise. So the types of weather reports, this is where we'll break down the detail and the information. The most common one that you'll deal with is a METAR. So if you dial up the AWOS here, 126.25, you'll get the local weather, automated weather, and it updates anytime it changes, every minute. So that gives you current conditions, and you can see that across your entire route. You can look a couple hours ahead of your destination. If you know the weather always comes from the west, you can see what's happening and not gamble and roll the dice, hoping that you can make it in, because that's not a plan. Planning is, you know, executing a flight is like 20% of it, 80% of it's planning and being ready for it. So, you know, having all the information you can will just take that much risk off your shoulders, so you don't have to deal with it in the air while you're trying to fly the airplane, navigate, communicate, talk to your passengers, keep the dog from chewing up the seat cover or something. So it is a standard international format, ICAO. I forget, and don't ask me what that means. International Civil Aeronautical Organization or something like that. METARs typically get issued. Now, this is where it's different because they're updated on the hourly, and I think it's 55 minutes past the hour, unless it changes, significant weather changes, like more than 5 knots or different more than a couple of, like 500 feet. I forget the exact number, but it'll be a specie. And you won't know in the air if it's a regular METAR or a special METAR, because it's all the same. It's just when you do your briefing, like in ForeFlight, or talk to a weather specialist, they'll tell you if it's a METAR or a specie. But otherwise, it's the same exact information. It's just the frequency at which it's updated. Here's an example. METAR. We said there's 2 types, METAR and specie. They're going to look the same, contain the same information. METAR is just hourly. Specie is if conditions change and they got to update it. So in this case, this is the METAR for Lancaster on the 16th of the calendar month at 17:53 Zulu, which Eastern Standard Time is 4 hours behind Zulu time, which is Greenwich Mean Time. When we file flight plans, we don't care about time zones because we cross them so frequently. So you file Zulu, and if my flight time is 2.5 hours, I just add 2.5 hours to that. I don't have to worry about, am I mountain, central, eastern, Nova Scotia, whatever, doesn't matter. This tells you it's automated weather. That could be an ASOS or an AWAS, AWS, and we can look at a sectional chart so you can see like what they are. Winds are 320. Yep, degrees, true or magnetic? Question.
Remember when it's magnetic?
True. Yep. True. That's okay. And the only, if you're in the middle of the country, is there a difference between true and magnetic? No, but over here, it's about 12 degrees plus. And as you go on the other side of the Mississippi, it's east. So it's plus or minus, it's plus degrees. So like 270 true is about 282 magnetic in this area of the country. And on the sectional chart, I can show you how you can tell what that is. But it's always true to the true North Pole. I can show you how to determine that later. But because of the magnetic variation and how it changes and it curves across the Earth, by doing true, it keeps it consistent on the maps. Its winds are 21 knots, gusting 26, 3/4 mile visibility with plus, which means heavy thunderstorms and rain and baby rain. That's how I remember BR, mist, and broken 800. Overcast at 1200 with cumulonimbus clouds. Temperature 18 Celsius, dew point 17, altimeter 2970. Remark pressure. I don't know. You know what? And I don't expect everybody to memorize everything, but know where to look it up. Yeah, it might be pressure front. Yeah, it probably is pressure front. And it's heavy thunderstorm and rain. These are pretty strong winds, and it's cumulonimbus, so it's probably a squall line. Not something I want to fly through.
Pressure falling rapid.
There you go. Thanks. 2970 is not too bad. Anybody remember what standard pressure is? 2992. And temperature? 15 what? Oh, which is how many Fahrenheit? Ah, sharp. I like it. Oh, I guess I could have just clicked through. I was quizzing myself. Yeah, so this is K. So in North America, in the US, all the for the lower 48 states, all the land airports start with the letter kilo and then 3-digit ICAO code. So Chester County is K MQS, Kilo Mike Quebec Sierra.
Why is it MQS? Why did they pick those letters? Is it just random?
What it is. Yeah, it's probably what's available and what they wanted. It used to be CTA in November 40. It was either 40 in November or November 40. I forget. I think it's 40 in November because we're right at the 40-degree line of latitude.
Gotcha.
So that's where we got the old airport number from way back. But no, there's many times they try for pilots, I guess, pick letters that like San Francisco's SFO, Austin is BOS, Newark is EWR, because that makes sense. You know? So and Orlando is MCO, right? So it's like doesn't always make sense, but you apply if you have a preference. Put it in. If not, they give you one. So 6 digits. So yeah, it's all the date and time is always 6 digits. The first 2 are the day of the month. They don't tell you what month it is, they just tell you what day it is, they figure, you know, what month you're in.
Interesting, you put the Z at the end for Zulu, because isn't it always Zulu, so it's redundant.
It's always Zulu, and it is redundant. They may publish things in local time. I don't know that I've ever seen it. But there's probably,
Some
it's
reason.
probably allowed. So if they didn't, they would put it here. Not totally. I can't think of a place where I ever got local time versus Zulu time. Auto just tells you. So AO1, there's AO1, AO2, and AO3. AO1 is no precipitation discriminator. 2 has it. 3, I think, has like surface sensors as well. So this is where winds aloft. If you're greater than 99 knots, it'll be a 7 up front for the wind direction. And that just adds 100 to whatever number is next to it. That's how you know. We'll come back to that. G just means gust, and if it's a variable, you'll see 2 directions with a B in the middle. If it's like swinging between 180 and 270, they'll say like 180 V, like they're 270, and then 2-digit wind speed gust with another 2 digits. If you don't see this is always in statute miles for visibility, because it's line of sight. Sometimes at the bigger airports, they have what they call RVR, runway visual range, and it's in feet. So sometimes you'll see like 1400. You'll see the runway number, and then some airports have visual measurement devices to give you that RVR for each runway. Yeah, so minus is light, no mark is moderate, and plus is heavy. That's the biggest thing. And then anytime you see VC, that's vicinity. So based on 3/4 mile, and what are the ceilings here? 800, right? The lowest cloud layer that's broken or higher is your ceiling. So 3/4 mile visibility, 800-foot clouds. Is that visual flight rules or instrument flight rules? Instrument. Lifer, actually, because it's less than a mile. That's pretty much bare bones to get in here. Clouds are good, but visibility is not. And then here's the breakdown. Sky clear, 0. Few is like 1/8 to 2/8, 1/4. Scattered, 3/8 to half. Broken is 5/8 to 7/8, and then overcast is pretty much more than that. Vertical visibility, you see, there's only 2 times that I've typically seen that. One is wildfire, like smoke. And the other one is temperature inversion, where you'll have smog or smoke or some other type of coastal fog come in. And with the temperature inversion, it's got nowhere to go, so it just sits there on the ground. Temperature dew point. Why is this important for pilots? Yeah. So if you're within 2 degrees, if those numbers are 2 degrees or less, you could literally be flying and then it goes around you and you're in the middle of the clouds. So if you're not instrument rated, not on an IFR flight plan, maybe not a great idea, because you can guarantee you get 1,000 feet off the ground, they're probably gonna be matched. And there you go. Pressure rising rapidly, pressure falling rapidly for a remark. And it's always in inches of mercury. So A is just for altimeter, 2970. There's not always remarks. Sometimes. Sometimes if there's other random type information, like occasional lightning in the clouds. What did this say? In the clouds, from the clouds to the ground. Not all lightning makes it to the ground, but a lot does. You'll see that in the remarks section. It's just another example of a letter combination that you would never remember off the top of your head. Hi, Brad. So the best weather information is that which your fellow pilot has just reported to you. Hey, I'm at 6,000 feet and I'm picking up a ton of ice and I just hit my head off the ceiling. You know, it's a good indication of moderate turbulence. So it's really, if it wasn't on the forecast, nobody saw it coming, but you know, hey, there's an issue between 6,000 and 8,000 feet. Maybe you want to stay a little lower. High reps are the best source of information for that. When I was coming back home Saturday night and the winds were really terrible, I won't tell you how bad. McGuire handed me off to Philly and Philly was like, yeah, someone tried to get in at that airport, but couldn't make it. So, let me know if you want to go somewhere else. Pirate, right? So a lot of times you'll hear on ATIS, they won't always say sky clear. Sometimes they'll say greater than 5 and 5. That means greater than 5,000 foot ceilings and better than 5 mile visibility. Anytime you're in unexpected conditions, like when I started picking up ice at 6 degrees C, and I was like, this is weird. I let ATC know right away. And you know, that helps them if you're on an IFR flight plan or getting VFR flight following. Hey, maybe I should reroute them from this area because it doesn't match my radar. Or let me give them a better route away from the center of this thunderstorm. Okay. PIREPs, they start with UA, unless they're urgent, then they're UUA. I don't know where that came from, besides maybe urgent announcement, meaning a recent PIREP. I'm sure Google can tell me the source of it, the origins. So this tells you the location over the GGG NavAid, because it's 3 characters, on the 090 radial, 25 miles out. The time is 1450. The altitude is in flight levels, so it's 060, 6,000 feet. The type of aircraft, every aircraft has a 4-digit code, which is what you use when you file. Like a Cessna 172 is a C-172. The Warriors are PA-28. The Piper Lance I fly is a P-32 Tango. So every type of aircraft you have will have a type number.
UA is unsolicited advisory and UUA is urgent unsolicited advisory.
Right. Great, thanks. And it is urgent and important. Sky is 8,000 overcast. It tells you the base of the cloud, and they'll give you tops. Sometimes, if they don't know the tops because they're in the clouds, they won't list it. But a lot of times when I'm flying IFR, ATC will ask what the base of the clouds were and what the tops were, so that they can compare it against the models that they have and the surface reports that they have. They can see if conditions are getting bad quickly that way. This just tells you it's a standard METAR. And they got this information from the METAR, winds 270-30, light turbulence, no icing, heavy rain. And there's 4 types of turbulence: none, light, moderate, severe. And 5 types of icing: none, trace, light, moderate, severe. And then for like thunderstorms, rain, snow, you have light, moderate, heavy. Upper air. Okay, so a lot of times there used to be one down at Aberdeen. I don't know if it's still there, but all over the country, more so out west, they will put a research balloon out to get winds and temperature information aloft, moisture, and they'll report that back with some type of radio transmitter down to the ground. And this is how you get your winds aloft information. It's the most common, but it's not done the most frequently because they'll measure lapse rates. It takes quite a bit of time for them to get up to altitude and stuff, and sometimes it'll just still have them parked at different altitudes. But it gives you a snapshot of weather information that could be very helpful. It's better than nothing. There's 4 types of radar: NexRad, next gen radar, terminal Doppler radar, airport surveillance radar, and then like airborne radar. Like most of the jets you fly commercially have a radar cone in the nose. So, and that's different than their radar altimeter, which measures their distance to the ground. This is like a weather radar. NexRad is the stuff you get from Sirius XM radio that links to your avionics, your higher end avionics in the cockpit. And then like your terminal radar is what the air traffic controllers are looking at. And let's see here. Satellite images. This will just give you an idea of cloud cover. You can get those right off, like the aviationweather.gov. You can pull them up on your electronic flight book. Many of those sources have it. And it's just another data point that you can see. If it's white, there's a lot of moisture. If it's not, then there's not a ton of moisture. Forecasts. So TAF, it reads almost the same as a METAR. It is, we don't have them here at Chester County, but at Lancaster and Philly, they have terminal aerodrome forecasts, TAF. And it's 5 statute miles from the runway complex center. They're valid for 24 hours and usually updated 4 times a day at 0, 6, 12, and 1800 Zulu. And they, like I said, use pretty much the same descriptors. In this case, it's at GSO Airport. Tells you the date on the 30th of the month at 1505 Zulu. From the TAF, these numbers here tell you it's valid from the 1500 on the 30th to 1200 on the 31st. These they'll break these down. This is what it is from the start time until 1700. So 15 to 1700, 050 7 knots, visibility greater than 6 statute miles, overcast 2,500 feet. From 1700 to 0200, it's basically the same, but the ceilings are going up 4,000. And then at 2,200, ceilings are back down, winds are coming back down, and so is the ceiling down to 2,000, and then by 900. Visibility is poor, overcast 800 and drizzle. So you'll get, it tells you like how the winds are gonna be shifting, speed and direction, how the visibility is gonna be moving. If you see P 6SM, that just means it's greater than 6. If you ever see CB, it's cumulonimbus. And usually that means thunderstorms. DZ, what other random, it's a minus sign, right? So that means light drizzle. Yep. Drizzle for shizzle. GFA. Area forecasts, graphical area forecast. Aviationweather.gov, that big interactive map with all the different layers and information. That's it. That's a digital interactive version of it. They give you current trends and surface information. There's a picture of it. This is just telling you, hey, I have convective sigmet here. Cloud tops are 41,000 feet. Unless you're taking your Cessna 172 up to 42,000 feet, probably don't want to go there. And then you'll have like marginal IFR, limited IFR. These are marginal down here, blue. And then you can actually like slide, you can turn on like turbulence, ice, winds, precipitation, and then slide this little slider out and kind of watch it move. It's kind of cool. Better than what it used to be, for sure. In-flight advisories. So you can, anytime you're in the air, you can go to a local, wherever you're flying, look on your chart, get the local airport weather information. If it's a tower, it'll have an ATIS. Most of the time, not every time. Most of the time, it'll have an automatic terminal information service. It's typically recorded by a person who's stationed at the field and updated hourly or whenever significant weather changes occur. And a lot of times there's a letter tied to it. So when you fly into like a towered field, the first thing they ask you, if you haven't told them, is do you have the weather and NOTAMs? And after you listen to it, it'll say information Zulu or information Tango, you know. It gives you the time, the winds, the weather, the altimeter setting, and then you go back and say like, you know, 16237 in Reading Tower, 16237 has Tango, you know, and they're like, okay, good. That way, if they give you a runway that you don't like based on the weather report, you have to say unable and request a different runway. And they will try to accommodate. AWOS is what we have here, automatic weather observation system. Sometimes you'll see ASOS, automatic surface observation system. That's the only difference. And it's an automated recording that will rewrite itself every time the broadcast repeats. AirMets. So there's like important information, AirMet, kind of like PIREPs. You got the regular ones and the urgent ones. You have AirMets, which are kind of like important, and then you have SIGMETs, which are like really important. These are issued every 6 hours and updated as needed. Anything like moderate icing, moderate turbulence, surface winds greater than 30 knots, IFR, mountain obscuration, you'll see that on AirMets. Zulu, and they have letters. Zulu is icing, Tango is winds, Sierra is like IFR, mountain obscuration. If you were to get, when you do your weather briefing on like, 1-800-weatherbrief.com, or you do an electronic briefing, you'll see it written like this. Some software tools give you auto decode where they give you plain English. But if you read it straight like this, it'll tell you, AirMet, mountain obscuration, Maine, New Hampshire, Vermont, Massachusetts, New York, PA, from, are, basically all these different nav aids will be the box that they draw on the map. And it just says obscured, occasionally obscured by clouds and precip and baby rain, aka mist, from 2 to 8 Zulu. Whoa. This is fun. So this gives you lots and lots of information. This pretty much looks like the winter time. Yep, February. So it's challenging to fly up here in the winter, because the jet stream does this wonky thing where it comes down to almost Florida. And so we get a lot of winds from the south, which is a direct crosswind to this runway, which makes it difficult to land. Depending on your aircraft, you also have turbulence because of that. The way the jet stream shifts around and the fronts, the pressure systems move across the country at that time of year. You see these lines here, these are freezing levels. So that's the other thing where, like right here, it says, boop, it's 0 degrees on the surface. So you can guarantee if you are anywhere near visible precipitation, aka rain or cloud or snow, you will get icing on your aircraft. And most single engine light aircraft are not certificated for flight into known icing conditions, aka peaky. So that's a big no-go this time of year. This little hat is turbulence. This color is surface turbulence. This one here, the lighter one, is high turbulence. I thought I saw a wind shear somewhere. Up there, low level wind shear. So like you could have winds in front of you at 20 knots, and then at the traffic pattern, and then by the time you come down, it could shift to 10 knots from the back, which is not great. So one, it makes it extremely bumpy going through that layer, and two, now you're landing with the wind, not into the wind, which is not a great idea either, because that just increases your ground speed. This tells you your icing layers. So like this is icing between 4 and 10,000 feet. IFR, precipitation, fog, and mist, aka baby rain. I got that from one of my military buddies. That's how they remember. SIGMAT, in-flight advisories. So AirMets are like kind of more hazardous to light aircraft. SIGMATs are hazardous to all aircraft. Pretty much anything that's in the air that's not nature. Last year. Severe icing, thunderstorms, severe extreme turbulence, clear air turbulence. Clear air turbulence is more like the tropopause and the jet stream, like at the higher altitudes, where you have like, the jet stream moving at a significantly faster speed than the air mass below it. Sandstorms, if you're in the deserts, or in-flight visibility less than 3 miles, like Canadian wildfires in 2023. That was fun. Volcanic ash, if you're like Mount St. Helens kind of thing, or Mount Etna. They're valid for 4 hours unless it's tied to a hurricane, tropical storm, then it's 6 hours. And they are unscheduled. They come out as needed. They have a different letter, November 3 Yankee. And they're reissued for the same weather phenomena, just with a new sequential number when they get updated. And they're by definition urgent and significant. Here's an example, Signet Romeo 2. Valid on the 10th. Until the 10th at 05:30. Oregon, Washington, I don't know why there's not a Zulu in there. So, because it says Zulu down here. So I think that might just be a typo. Oregon, Washington from Seattle to Piedmont to Eugene, back to Seattle. You know, it's kind of like a triangle. Occasional severe clear air turbulence between flight level 28,000 and 35,000 feet due to the jet stream. Conditions beginning after 200 Zulu and continuing beyond 5:30, which is the Sigmet's valid for, because Sigmet's are only valid for 4 hours. Convective Sigmet is hazardous convective activity. So this is where you have very serious and significant updrafts, either from the uneven heating of the earth throughout the day, or the low pressure systems, or a combination where you have like a huge chimney, basically. And there are times, anytime you have surface knots greater than 50 knots, hail at the surface, greater than 3/4 inch in diameter, tornadoes, swell lines, like that type of stuff. Or, that a frontal system that covers like a huge swath. This says heavy precip greater than 40% of an area or more than 3,000 square miles.
So Sigmet without the Z could refer to a severe weather advisory for hazards such as icing, turbulence, dust storms. So it seems like that's a.
That's what the Sigmet is. The convective Sigmet is for basically thunderstorm activity.
But without that Z, remember you went back to the time and didn't have Z for Zulu.
Yep.
So I'm thinking they're referring that they omit the Z, possibly to indicate that it's a very severe condition.
I'm not totally sure. I think it's a typo on that slide.
Yeah.
So convective Sigmets, just so you have an idea, there was a report recently of a 182 over Indiana or something. His nose was pointed down, his power was at idle, and he was still climbing at 1,500 feet per minute because he was stuck in an updraft. What's that?
What a weird phenomenon.
Every thunderstorm is pretty much, you can get 2,000 to 3,000 feet up. Somewhere in the middle of the country last week. But that's just an example of why we avoid thunderstorms and updrafts, because what goes up must come down, and there are downdrafts that occur once you get to the mature stage of a thunderstorm, if you remember. And they can be significant, and you could be at full power still going down 2,500 feet per minute, and that's going to hurt. So you just avoid that at all costs. So in this case, severe thunderstorms moving from 240 true or magnetic true at 45 knots. That's pretty typical speed in the 40s. And the cloud tops are above 45,000 feet, so don't think you're going over it. Wind gusts at least 60 knots. Hail up to 2 inches. 65 knots possible. My steady state winds at 4,000 feet on Saturday night were 63 knots. Took me a long time to get home. Effective outlook basically for the next week. This chart will give you, this says categorical outlook legend. That's kind of like a percentage of possible thunderstorm activity. And it gives you the time it's issued, the day of the outlook, and like when it's valid from. Day two. So as you can kind of see the storms moving across the country. So if you want to see like general weather patterns, say you're working for a charter company going on a week-long trip across the country, you kind of see if you're going to run into problems just by looking at an outlook. Here we go. Winds to temperatures lost. I know we come back to it. Forecasts are made twice a day based on those balloons that we talked about earlier. If the wind is greater than 99 knots, but less than 199 knots, adds a 5. So you get takes 100 off the speed, adds a 5 on direction. So if it's 270, it's 770. And it's, if it's not confusing, let me see if I can get, here we go. So there's only 360 degrees, and they only have 2 digits for the wind speed. So it's take 5 off the front, it's 119 knots, and the temperature is minus 60 degrees. Once you get past, it'll say plus or minus when you're near the freezing level, and once you get way above the freeze point, below the freezing level, we just drop the minus. This is like, yeah, you know, it's negative that high. It'll tell us what altitude this specific reading's from, but we can get it from another one. When it's the wind is greater than 200 knots, they just call it 7799. Because it's fast. And the jet stream is frequently in those speeds. Oh, when there's no wind, less than 5 knots, light and variable, it'll be 9900. 99 for direction. 99 problems, but wind isn't 1 because it's 0. Here's an example. They don't give you when the surface, because Denver is like a mile-high city, right? They won't give you the winds aloft until it's greater than 3,000 feet above ground level. Tells you when it's valid, and here's where it says temps negative above 24,000 feet. So they're just like, everything's negative a lot. So we can drop the minus sign. It's a legacy way of printing, but they still do it. So like you got Denver, St. Louis.
So they do Denver at 24.
24,000 feet, yep. So it's winds are 240 at 41 knots, temperatures minus 31.
So 1900 at 141. Like minus 5 plus 100, or
No, if it was a 7,
or
if it was 7441, then it would be 240 at 141 knots.
The CFP one, 7302.
Here,
oh, okay.
so it's winds are 230 at 106 knots, temperatures minus 49 degrees Celsius.
Got it.
Is there a calm wind anywhere? Probably not. Usually there's not calm wind at temperatures aloft or aloft unless you have a temperature inversion. And you're right at the layer where the winds, like the surface front, it's going this way, but the upper level winds are going this way. Right where that layer is, it'll show 0. But I guarantee you, as you fly through it, it will not be comfortable. Surface analysis chart. Updated every 3 hours for the lower 48. They give you like, kind of like everything we looked at earlier. We walked through one. The gray lines or black lines, depending on how it's printed, are isobars, and they're areas of equal pressure. The values of the center of the high or low pressure systems are underlined in millibars. So we looked at this earlier. You had your highs, had your lows. How about this? Oh, here's your purple. You said occluded. You said occluded. There you go, right there. And there's another one there. What's this orange dashed line? Trough. Yep. Which is high or low pressure. Yep. And if it was high pressure, it'd be called a ridge. Oh, awesome. Love it. I think, is there anything else we didn't cover? Does anybody see anything that anybody has questions on that they're not sure about? Chart. All right. Okay. Low pressure in Canada, British Columbia. Which way are the winds going above the low pressure system? Because it spins counterclockwise, right? Yeah. There you go. There's the different types. Cold front, warm front. I don't know what I want to be when I grow up. Stationary front, occluded front. That just means a whole bunch of fronts are running into each other at the same time. Trough or boundary outflow. Small line. Anytime you have like what do they call it? Directions or something like that, where you have like it's like a really thin line of like thunderstorms that could spawn off tornadoes. Anytime you see that, you'll see this symbol. They'll try to fly through it. Dry lines, tropical waves, trail wall, and I forget what that means, so I'll have to look it up. Occluded is where you have multiple. There's a couple different types of occluded fronts, but it's where you have multiple fronts running into each other. You can have like a warm occlusion or a cold occlusion. And it's like you'll have like a warm front, a cold front running into a warm front with a colder front, squeezing it into from behind. Is an example. Low level significant weather prog chart. So this only tells you like marginal VFR, IFR, freezing levels, turbulence, stuff like that. Basically weather hazards that are forecast, and it's prog, right? So it's prognostic. So it's a forecast outlook type chart. They're great for planning. But for departure and estimated arrival, you should use current conditions in conjunction with prog charts. You should not solely rely on prog charts. That's just giving you kind of like an outlook briefing, a go, no go, based on your personal minimums and aircraft type.
And troll, is a weather phenomenon. When warm, moist air wraps around a cyclone, it's typically used in Canada weather forecasting during the winter.
There you go. Gotta love Google. So typically they're valid from the surface to 24,000 feet. They're issued for 12 and 24-hour windows, and you'll see them split next to each other. The 12 is usually on the left, 24 on the right. They'll tell you the issue time. In this case, it's 00 Zulu. And this is the legend down here. Red is IFR, which is the same color as IFR. Same with blue for marginal, except it looks like a cloud. The orange dashed line is turbulence. The dashed line is your icing level, and you'll see a number associated with it, like right here. How many feet is that? 120? 12,000, right. If you see this jaggedy type line, that means it's like right here. That means it's freezing at the surface. What else? That's about it. Freezing level down in Florida is 16,000 feet. That's pretty nice. And this must be 12,000 feet. This must be like the spring or the fall, and it is. It's October. ATC radar. Doesn't always look like that, and it's not super reliable. It's not terrible, but it is not the level of detail that you would get from airborne radar in your like nose cone or aircraft or NextRad, but it has gotten better. One thing you cannot do when you do your pre-flight planning is, even if you have XM radio or ADS-B in, where you have weather information being loaded into the GPS or your primary flight display, it could be as much as 15 minutes old. So do not use it if you're trying to thread the needle between thunderstorms or something like that, because odds are that hole is gone. EFBs, same thing. Basically like NextRad weather, but there could be a delay. The delays are getting shorter as time goes on, but depending on the location of the country and the frequency of the updates, could be as much as 15 minutes behind. So always check the age. If the front's moving this way and you're flying south to north, it's always good to go behind it, not in front of it, unless the winds are awful. We talked about ADS-B, FISB, Flight Information Service broadcast, so that comes over on the 978 data link. There's two frequencies, 978 and 1090. But any ADS-B in systems that are connected to avionics, or for example, if you use a Stratus or a Sentry type ADS-B device that you can connect to your ForeFlight or iPad or something like that. Once you're airborne, you do have usually established communication to ADS-B ground stations and can get this information to pop up on like your radar layer on your handheld device. Not always, but when it's there, it's another tool. So that, if you can't, if you don't have access to electronic data like this, look on your chart, call up flight service, you can ask. All right. What was, or is, because we're looking at it, the date and time of this report? Bravo. Ding, ding, ding. 15:05, it's the first of the month, first two digits are the day of the month. Next four are Zulu time. Good work. Lowest ceiling. Why would Bravo be incorrect? Bingo. Which of the following weather sources would show areas of turbulence? And why is that? METAR is surface condition, TAF is a forecast. Radar is like visual representation of precipitation in the air, and AirMet is a warning. Good. How long is a TAF, terminal aerodrome forecast, valid for? Kind of a trick question, because they threw a bunch of hours at you. Survey says 24 hours. Yep, 24 to 30. So it's usually a day. Could be a day for 6 hours. They are reissued at 6 hour intervals. So that's why some people could get confused by that. Planning for a flight tomorrow evening. What type of weather briefing would you get? Yep, Outlook. Forecast is not a type of briefing. It's a standard abbreviator Outlook. What are the clouds going to be at 2000 Zulu? Broken. And why is that? So this is valid, right? 01 at 1700. And this was issued at 1641. So from 1700 to 0200, this is valid. Does everybody get that? So like from this time to the next time, that's what this is applicable to. And then this is from 2 to 8, it's this. From 8, it's this. From 8 until 12, right? Because that's the end of the tab. That last one. And for extra credit, what are the winds, visibility, and the conditions? Yep, 050, 4 knots, 5 statute miles, light rain, yep, this is the minus sign. And mist, aka baby rain. I love that, I'll never forget it. Every time, I'm like, hey. All right, forecast valid times for this tab. What is this tab valid for? Kind of gave it away when we broke down the last one.
441,202.
Alpha Bravo Charlie Delta. It's Alpha?
Yeah.
Final answer? Alpha. And why is that? The first two are the date. So it's, I know, that's kind of a trick question. I'll have to get that feedback on that. Because they don't, this one has date, like the way the times are written, 4 digits with a Z means time. But 01, 02 from up here is the day. Right, so it's kind of a little bit of a trick question. I don't love that one, but biggest limitation of NextRad and in-cockpit radar displays is delay of information. All the above. Oh, Bravo is correct, but so is everything else. Screen is really small, it's turbulent. You're trying to read the screen while you can't even see outside the cockpit, and it's 15 minutes old because you're already in the suit. And that's it. Questions? So we pull anything up, look at answering map related legend type questions? You don't have to stick around if you don't want to. Where is the sign-in sheet? Somewhere, go. Make sure everybody signs in if you haven't. Right here.
Oh, okay.
You dodged the pointer if you with that. Remember?
This? Yeah, I did.
It locks up with everybody else.
Well, I found out.
Move at a certain cadence.